got 1, 2, 3, 4, 5, 6, 7, 8.
So you decompose. You're the first one I've seen all day do that.
We know that when students can navigate and connect multiple representations of a math concept, they form more meaningful connections. In this video, we look at a particular 6th grade teacher's enactment of making connections. The strategy we will be investigating is specifically connecting to more than one representation of an idea.
The lesson that I was doing with students today was finding area by using mixed fractions, so they were not whole numbers. They were fractions, for instance, in a rectangle, where a rectangle would have a length of 3.5 inches and a width of 2 1/4 inches. And they had to use those fractional parts to find the area of their rectangle.
This is the math task from Open Up resources being used in this video. Please consider pausing here and solving the problem yourself.
You have 2 ways that you've learned to find area. Okay, pick one. You've got to split it in half. Then I'm going to send you to the board. Each square is 1 unit in length on the edge.
The teacher uses 1/4-inch graph paper to help her students draw the area of the rectangle with fractional side lengths using accurate measurements. The teacher had previously discussed with the students that the area of 1 square is 1/16 of a square inch. The students then found the area of the rectangle.
I want to bring this to your attention. Some of you were counting. You were counting squares. And how many squares are there in here?
126.
How many?
126.
This is square 1. This is square 126.
The teacher used student ideas to show the connection between the representations of finding area. The students diagrammed the situation and verified the area found from the algorithm with the amount of square inches represented from the visual.
The algorithm. So I replaced the length with 7/2, which is what this is. The width with 9/4, which is what that is. Same thing as we did yesterday. We could go to the graph paper, we could draw, we could shade. Okay, but let's multiply this. What's 7 times 9?
63.
What's 2 times 4?
8.
We get the same area we got by multiplying if we're counting squares?
Yeah. You did. It's just in an even more reduced.
You think it's in a more reduced form? Are all those groups of 16?
Yep.
Are you sure? Positive? Let's count, because we should get the exact same thing. This is a good learning one. Look at this extra one. How many squares does it have?
14.
How many does he need for a group?
2 more.
He needs,
16.
what's 14 16ths reduced?
7, 8.
We hope you enjoyed learning about EAC1, specifically connecting to more than one representation of an idea. To learn more, go to rootmath@boisestate.edu.